Hello everyone, in this video we're going to talk about even and odd degrees and even and odd functions. So let's start with some vocabulary here. So a graph, you could decide if a graph has an even or odd degree just by looking at it. So an even degree graph, like the one on the left here, both arrows on the end go in the same direction. And an odd degree graph, like the one on the right here, both arrows go in opposite directions. So determining whether a graph has an even or odd degree is just a matter of looking at the arrows. Even goes in the same direction, odd goes in opposite directions. Now, if they do not give you a graph, all you have to do is look in the problem and find the highest exponent. And if it's even, then it's an even number. Or if it's an even number, then it's even. And if it's an odd number, then it's odd. Now, if a term or terms have multiple exponents, like if it was 2x squared y squared, remember to find the degree of a term, you add up all the exponents, right? So if they just give you the equation, look for the highest exponent. And if terms have multiple exponents, you got to add them up before you tell me what the exponent is. So that's even and odd degree. Now let's talk about even and odd functions. So this is separate from even and odd degree. This is just even and odd functions. So graphically, if a function is even, that means it's symmetrical across the y-axis. So the two on the left here are symmetrical across the y-axis. Remember, the y-axis is the up and down axis. And symmetrical across the y-axis means everything on the left, if I fold across the y-axis, I'll make everything on the right side of the y-axis. And you can see that the left two are symmetrical across the y-axis. The two on the right are odd functions. If it's an odd function, it has 180 degree rotational symmetry about the origin, and it must go through the origin. So that sounds really complicated, but all that means is that everything in the top left quadrant, if I spin it and put it down here, it's the same. It's upside down and backwards, right? We rotated it 180 degrees. And the same goes for every one of the four quadrants. If you point at a quadrant, if you spin it 180 degrees, it should be the exact same picture, and all four quadrants should do that. And a really easy hint is if it doesn't go through the origin, it's definitely not odd, right? So if it goes through the origin, it's a good first indicator. You can see both of these have rotational symmetry around the origin. If I were to pick up the graph quadrant, let's say this one, and I were to rotate in 180 degrees, which is two quadrants, I get the same picture. 180 degrees, it should be upside down and backwards, which it is. And if all four quadrants do that, then that means it has 180 degrees symmetry, rotational symmetry around the origin. And that means it's an odd function. Now, functions can be neither even nor odd, and if that's the case, then neither of these things are true. It doesn't have reflectional symmetry across the y-axis, and it doesn't have rotational symmetry 180 degrees around the origin. It's impossible for them to be both, but it is possible for them to be neither. Now, if they do not give you a graph, there's all these rules, which are a little complicated. I'll leave them on the screen here for a second, but then I'm just going to show you an example here. If a function is even, then basically what that means is plugging in an x and plugging in a negative x gets you the same answer. So if I plug in 5 into an equation, and then I plug in negative 5 into that equation, I get the same answer. That means it's even. And odd means if I plug in negative 5, let's say I get 12. If I plug in positive 5, I will get negative 12. So that means when you change the x to its opposite, the answer also changes to its opposite. And if that's true, then that means the function is odd. And if neither of those things are true, that means that it's neither even nor odd. So let's look at an actual example of that, because that's complicated the way it's worded here. So here we go. We have, we're going to look at question 7 here. And we're going to see if either all three of these are even, odd, or neither. So they've given us an equation and they've given us a table of values and they want us to plug them all in. Now I'm just going to use my calculator. I'm just going to go to the y equals screen and I'm going to type in 4x squared plus x to the 4th. And then I'm going to go to the table and I'm just going to copy down the values I see here. So -2 is 32. -1 is 5. 0 is 0. 1 is 5. And 2 is 32. So if this is an even function, then plugging in opposite values should get me the same answer. Look at that. Plugging in opposite values got me the same answer. So when that happens, it's an even function. All right, now let's try the second one. 4x to the 3rd plus x to the 5th. And when I plug in these values, I get -64, -5, 0, 5, and 64. So when I plug in negative x's, I get negative y's. When I plug in these negative x's, I get negative y's. If that's true, then that means the function is odd. So the first one, I plugged in negative answers and I got the negative x's and I got the same answers. So that was even. And I plugged in, for this one, I plugged in opposite x's and I got opposite answers. That means that it's odd. And remember, odd, a good indicator is if you see it go through the origin 0, 0. That doesn't mean it's definitely odd, but that has to be true for odd. And then this last one is neither. And I can't see the equation, so let me. That's a 4x squared plus x. 4x to the 4th, sorry, plus x. I already know the answer is neither, which means that neither of those things are true. Okay. 4x squared plus x. And my values here are 62, 3, 0, 5, and 66. So remember, if it's even, these two numbers should be the same because these are opposite x's and they're not. And if it's odd, these two numbers should be opposites because the x's are opposites. And they're not. So that means that this third one is neither even nor odd. So that's today's video. That was even and odd degrees and even and odd functions. That's all for today. Thanks for watching. Have a good day.